1960, a signature was placed on a commercial contract that quietly removed one of the most important names from the British sitting room. Standard Telephones and Cables sold its Braemar valve division to Thorn Electrical Industries. The dedicated glass manufacturing factory at Footscray in Kent was abruptly handed over. The production lines shifted ownership. The brand that had glowed inside millions of British radio receivers, quietly powering the national broadcasting habit, was traded away to a competitor without a single moment of public mourning. A decade earlier, that same name had meant precisely the opposite. It had been the undisputed foundation of British listening. Standard Telephones and Cables, almost universally known as STC, did not merely build radios. It built the vast physical infrastructure that made the radio set possible. It had manufactured the line amplifiers, the colossal transmitters, and the submarine cables that carried voices across borders. It had even co-founded the British Broadcasting Company in 1922. STC was the invisible giant standing behind every tuning dial in the country. But the real story of STC in Britain is not just the sale of a valve factory in Kent. It is the story of how a sprawling engineering empire built the foundations of British wireless, powered the post-war domestic listening habit, and then methodically erased its own name from the high street as the market shifted ruthlessly from wooden domestic cabinets to global telecommunications. Every week, we tell the stories of British radios, wireless makers, and listening habits that once shaped how people heard voices, music, and memory, and what happened when the market moved on. Subscribe if that history matters to you. The story begins not with nostalgia, but with a specific place, in London, in 1883. Before a wireless set, an older British term for a radio receiver that brings broadcast signals into the home without a physical program source, could confidently sit on a British sideboard. The infrastructure of communication had to be laid by hand. Before the BBC gave the nation a unified voice, early wireless experimentation in Britain was a fractured, frustrating landscape. Enthusiasts and early domestic listeners relied on fragile parts, unpredictable voltages, and erratic reception. There was no true standardization in the domestic market. If a component failed in a darkened sitting room, finding a reliable replacement was often a costly gamble. The British listener fundamentally lacked a robust, mass-produced, industrial-grade heart for their receiver. In May 1883, the American company Western Electric opened a small office and store in London, operating under the name International Western Electric. The initial objective was not domestic entertainment. The objective was industrial and civic communication. They sold American-designed telephones to the very early British telephone exchanges. But by 1898, the company required a permanent manufacturing foothold on British soil. They acquired a failing electrical cable factory at North Woolwich, situated in the industrial mud of London's East End. In its earliest years, this Thameside factory merely assembled equipment using parts shipped across the Channel from Belgium and across the Atlantic from the United States. But the long-term ambition was total British manufacturing independence. The pivotal shift toward the domestic listener arrived in 1922. The company acquired the sprawling John Tyler engineering site at New Southgate, an area that had originally served as a Victorian cemetery station. This vast expanse of land in North London was rapidly redeveloped throughout the 1920s to manufacture telephone and radio equipment at a scale Britain had rarely witnessed. In that exact same year, 1922, the company joined a consortium of heavy-hitting competitors, including Marconi, GEC, and Metropolitan Vickers, to establish the British Broadcasting Company, the entity that would shortly become the BBC. The engineering directors understood a simple, structural truth. A mass market for domestic receivers could only exist if there was a reliable, powerful broadcast to listen to. The BBC needed massive transmitters to send the signal. The public needed receivers to catch it. The company positioned itself to build both. In September 1925, the American parent company sold off its international operations to the International Telephone and Telegraph Corporation, widely known as ITT. The new corporate owner immediately renamed its British operation. It became Standard Telephones and Cables Ltd, or STC. It was a name that would remain unchanged for over 60 years, slowly weaving itself into the physical fabric of British broadcasting. Under the new STC banner, the company sought a way to expand its reach directly into the physical homes of the British public, beyond the telephone exchanges and transmission towers. The mechanism for this domestic invasion was the electronic valve, a glass electronic device used to control and amplify signals before transistors replaced it. In the early days, almost all valves in Britain were either directly supplied by Western Electric or based entirely on their patents. But as the BBC expanded its broadcast reach from London and the massive new Daventry transmitter, STC realized that every single radio required constant, inevitable replacement parts. Valves burned out, glass darkened, filaments failed. The high street repair bench was about to become a highly lucrative pipeline. In 1934, STC introduced a brand name that would become an absolute legend in British radio repair: Brimar. The name stood for British Manufactured American Radio, designed to offer American technical standards built entirely by British labor. These valves were manufactured at a dedicated, state-of-the-art factory in Footscray, Kent. The financial and industrial investment in this facility was staggering. Historical records suggest that by the late 1930s, the Footscray site alone employed over 3,000 workers, a vast army of engineers, glass blowers, and assembly line operators dedicated to perfecting the vacuum tube. For the British consumer, the Brimar valve brought industrial reliability into the domestic sphere. It was not a cheap, disposable item. In 1937, a typical Brimar 6v6 output valve, essential for driving the loudspeaker, might cost around 10 shillings and sixpence, Takilud 10s 6D. Adjusted for inflation, that is roughly equivalent to £35 today. It was a premium component, ordered from massive trade catalogs by local radio shops and installed by qualified service engineers. Early reviews in trade magazines like Practical Wireless praised their rugged construction, noting that STC had successfully adapted the rigorous standards of telecommunications infrastructure for the ordinary British sitting room. STC was no longer just laying heavy tar-coated cables in the mud of North Woolwich. It was glowing warmly in the corner of the house, turning an invisible broadcast from Droitwich into a human voice. The breakthrough for Standard Telephones and Cables was not immediately a single wooden cabinet or a beautifully molded Bakelite radio. STC's true breakthrough was establishing an absolute, quietly dominant moat over the internal electrical architecture of British communication. While other consumer brands aggressively fought for window space in the high street electrical shops, STC focused entirely on the fundamental components that made those very radios function. They understood that a domestic wireless set was only as reliable as the glass vacuum tubes glowing inside its chassis. A valve radio, a radio that uses glass electronic valves to amplify and process signals before the transistor era, was a fragile beast. The Brimar valve line became STC's industrial Trojan horse into the British domestic market. To the average British listener sitting in a darkened front room, the wooden cabinet on the sideboard might have carried the badge of Murphy, Bush, or Ikeko. But inside the dark, dusty chassis, the glass envelope often carried the distinctive STC Brimar stamp. Consider the physical reality of a Brimar valve from the late 1930s. It was a masterpiece of constrained British manufacturing. The glass was thick, the internal metal elements were perfectly aligned by Footscray engineers, and the vacuum seal was rigorous. when a local service engineer removed a failing valve from a customer's set and opened a fresh Brimar replacement from its distinctive blue and yellow cardboard box, they were holding industrial-grade telecommunications technology scaled down for the domestic sitting room. STC charged premium prices for this reliability. A set of replacement valves could easily cost the equivalent of a modern family's weekly food shopping, but the high street repair bench trusted the Brimar name implicitly. To secure their consumer flank, STC did not just supply parts to others. They bought their way directly onto the high street shop shelf. In 1938, STC fully absorbed the Colster Brandes (KB) radio company, shifting its manufacturing base in Footscray to run alongside the Brimar valve plant. Colster Brandes radios gave STC a direct branded line to the consumer cabinet market. A pre-war KB mains receiver might cost around 15 guineas, an immense sum roughly equivalent to over £1,000 today. For that price, the British listener received a beautifully veneered cabinet, a highly sensitive tuning circuit, and a full complement of Brimar valves. But the British radio moat that STC built was far deeper than a single Colster Brandes cabinet. At the new Southgate factory, STC engineers were simultaneously building the massive transmission architecture that made the BBC audible across the nation. The tuning dial, the scale or display that shows which station or frequency the radio is tuned to, relied entirely on a strong, uncorrupted broadcast signal. STC provided the heavily shielded line amplifiers, the pioneering coaxial cabling introduced in 1936, and the microwave radio sets, with aerials less than an inch long, manufactured in their advanced Hendon facility. This meant that STC effectively owned both ends of the British listening habit. When a BBC announcer spoke into a microphone at Broadcasting House in London, that audio signal was often carried over STC copper cables, amplified by STC line equipment, routed through STC exchange gear, and transmitted out from the massive Daventry or Droitwich transmitters using STC infrastructure. Finally, it was pulled from the air by a domestic aerial, a wire, rod, or internal component that receives radio waves from the air, and amplified inside the home by an STC Brimar valve. They owned the current that flowed beneath the entire broadcasting ecosystem. The endorsements for this level of engineering were not found in celebrity advertisements, but in institutional reliance. The General Post Office, the Admiralty, the Royal Air Force, and the BBC all heavily specified STC components. When war approached in 1939, this reliability became a matter of national survival. STC completed a total blackout of the new Southgate factory. They installed an elaborate internal loudspeaker, the part of a radio that turns the electrical signal into sound moving through air, system throughout the vast works. This emergency network was connected to a reinforced underground headquarters that could withstand anything short of a direct hit by a high-explosive bomb. By the time the Second World War demanded total industrial mobilization, STC employed many thousands of highly skilled workers across New Southgate, North Woolwich, and Footscray. When a radio repairman in a high-street shop ordered replacement parts from a trade catalog, Brimar was the absolute standard. The valves were stacked on the wooden shelves of local service counters from Glasgow to Oxford. The Footscray plant was churning out millions of valves, ensuring that wartime households could still tune in to the BBC Home Service for vital news. The listener did not need to understand the complex physics of thermionic emission. They only needed to know that when they turned the bakelite volume control, the knob or slider that changes the loudness of the sound, the voice of the newsreader would emerge clearly from the static. STC had successfully bridged the gap between the colossal power of the BBC transmitter and the intimate space of the British home. The badge on the dial was not decoration. It was a promise about reception. The glory years of standard telephones and cables represented a scale of British manufacturing that is difficult to comprehend in an era of global supply chains and outsourced offshore assembly. To understand STC at its absolute zenith in the 1940s and 1950s is to understand a corporation that did not merely participate in the British radio market. It actively engineered the physical environment in which that market existed. New Southgate built the massive telephone exchanges. North Woolwich drew the heavy submarine cables. Footscray blew the glass and evacuated the valves. Ilminster manufactured the highly specialized military tubes. Treforest in South Wales expanded the component assembly lines. Harlow conducted the advanced telecommunications research. Broadcasting House provided the authoritative voice. Droitwich carried the long-wave signal. The High Street Electrical Shop sold the finished cabinet. The British front room made it a daily habit. The foundation for this post-war dominance was forged in the absolute, uncompromising necessity of the Second World War. Between 1939 and 1945, the STC factories were an immovable pillar of national defense. The consumer radio market was suspended, and the entirety of STC's engineering might was redirected toward keeping the country communicating, navigating, and fighting. At New Southgate, engineers developed the crucial OBOE bomb guidance systems, a highly accurate blind-bombing radio targeting system that relied entirely on the flawless performance of STC thermionic valves. They built the instrument landing systems that guided heavy bombers back to fog-bound British runways. The work continued under extreme duress. The New Southgate facility was a prime target for the Luftwaffe. In August 1944, a V-1 flying bomb struck directly between Buildings 6 and 8 at the New Southgate Works. The blast was catastrophic, resulting in 30 deaths and over 300 severe injuries among the workforce. Yet, the surviving workers cleared the shattered concrete and twisted steel. The production lines were painstakingly restarted. The military-grade valves kept coming. STC was quite literally keeping the nation's communications alive under fire. When peacetime returned, the British public demanded domestic radios to replace their exhausted, makeshift wartime sets. The BBC Light program, a national radio station established in 1945 to provide light entertainment and music, poured from table radios in sitting rooms across the country. Inside a vast number of those sets, whether the badge on the front said KB, Ferranti, or Murphy, Brimar valves burned brightly, driving the audio output stage with perfect clarity. STC was printing immense, thick trade catalogs, supplying thousands of high-street radio dealers, and stocking the repair benches of the entire nation. By the time the British economy fully stabilized in the early 1950s, STC was a sprawling industrial leviathan. The company employed over 25,000 workers across its British sites. At the Footscray plant in Kent, the production of Brimar valves was an industrial ballet of extreme heat and microscopic precision. The glass envelopes were formed. The air was entirely evacuated to create a vacuum. The delicate tungsten filaments were sealed. STC was producing millions of valves annually, ensuring that no radio repairman in Britain was ever more than a telephone call away from a Brimar replacement. While the heavy copper cables and towering microwave relays formed the invisible skeleton of British broadcasting, the domestic face of STC required a wooden cabinet, a tuning dial, and a speaker grill. They possessed this direct consumer connection through Colster Brandes, heavily branded as KB, operating straight out of the massive Footscray complex alongside the Brimar valve plant. By the 1950s, KB radios and radiograms, a substantial piece of domestic furniture combining a radio receiver, amplifier, loudspeaker, and record player in one cabinet, were aspirational fixtures in the British home. They were heavily promoted in magazines like Practical Wireless and The Radio Times. But KB's greatest post-war triumph was the FB-10, affectionately known by listeners and later collectors as the toaster radio due to its distinctive shape. Introduced in 1950, the KB FB-10 was a compact, highly efficient mains radio, a receiver powered directly from the household electrical socket rather than internal batteries. It featured a smooth, curved plastic cabinet, an internal aerial, and, naturally, a full complement of highly reliable Brimar valves. It cost around £8 and 15 shillings, roughly equivalent to £280 today. It was affordable, modern, and perfectly proportioned for a bedside table or a kitchen worktop. It sold in the tens of thousands. The STC footprint extended far beyond the domestic kitchen. They outfitted the entire public address and internal radio systems for the great British ocean liners, the Queen Mary and the Queen Elizabeth. In 1946, STC established Standard Telecommunication Laboratories, STL, in Harlow, Essex. This sprawling facility was dedicated entirely to advanced telecommunications research and development, slowly shifting its focus from glass valves toward solid-state physics and advanced transmission mediums. But STC's peak British presence in the 1950s was not a single, isolated object. It was a ubiquity of parts. It was the physical reality of a dark winter evening in 1954. Picture a KB radiogram sitting heavily on a carpet in a suburban sitting room. The room smells faintly of coal smoke from the fire, and the warm, slightly metallic scent of dust settling on hot glass valves. The tuning dial, a large glass scale printed with the names of distant European cities like Hilversum, Kalundborg, and Athlone, glows a soft, golden yellow in the dim light. The listener turns the heavy bakelite tuning knob, hearing the mechanical scrape of the tuning capacitor, a component that changes the circuit's tuning so the radio can select one station from many. The static rushes through the large paper cone loudspeaker until it suddenly snaps into the clear, authoritative voice of a BBC newsreader on the home service. That single domestic moment relied upon an entire unbroken chain of STC engineering. The signal was broadcast over STC transmitters. It traveled through STC cables. It was pulled from the air and amplified by STC Brimar valves. It was played through a KB cabinet built by STC workers. The scale was absolute. The company was deeply, structurally embedded in the daily ritual of British communication. It was an end-to-end empire of sound, built on the assumption that British engineering, heavy manufacturing, and the glass vacuum tube would dominate the high street forever. The decline of a British radio and wireless empire is rarely the result of a single, catastrophic engineering failure. It is almost always the result of overlapping structural market forces arriving in sequence, slowly dismantling a business from the inside out. For standard telephones and cables, the tragedy was not a lack of technological foresight. It was a calculated, deeply unsentimental corporate choice to walk away from the British front room. The British turning point arrived precisely in 1960. The executives at STC looked at the rapidly changing landscape of domestic electronics and made a decision that permanently severed their physical connection to the British listener. They sold the entire Brimar valve and cathode ray tube division to their fierce commercial rival, Thorn Electrical Industries. It was not a bankruptcy. It was a deliberate, strategic retreat. The massive Footscray plant in Kent, which had pumped millions of glowing glass vacuum tubes into the domestic market, abruptly shifted its ownership. The foundation of the STC domestic empire was unceremoniously traded away. This decision was driven by the first of 5 immense pressures dismantling the traditional industry. Force 1, British cabinet, valve, transistor, component, labor and manufacturing costs. Producing a Brimar valve was an exercise in highly expensive, incredibly precise British skilled labor. It required vast glass-blowing infrastructure, vacuum specialists, and intense manual assembly at the Footscray site. But the transistor, a small electronic component that controls or amplifies signals with less heat and power than a valve, had decisively arrived. Transistors did not require glass envelopes. They did not require delicate heated filaments. As component costs and domestic labor costs rose, STC executives looked at the balance sheet. They realized that the profit margins on cheap domestic radio parts were collapsing. STC was an industrial telecommunications giant at its core. When forced to choose between the increasingly low-margin domestic consumer market and the vastly profitable, heavily funded world of global telecommunications, military radar, and submarine cables, they chose the infrastructure. Force 2. BBC standards, license culture, and reception expectations. The British listening habit was fundamentally shifting beneath STC's feet. The BBC was heavily promoting the expansion of its VHF-FM network, a radio band that gives clearer sound over shorter distances than older AM bands, entirely free from the crackle and atmospheric static of medium wave. Simultaneously, the public was demanding the portable radio, a radio designed to be moved from room to room or taken outdoors. The heavy, mains-powered valve radio, which required a warm-up time and a substantial electrical supply, was suddenly viewed as outdated and cumbersome. Listeners no longer wanted a massive piece of wooden Colster Brandis furniture dominating the sitting room. They wanted a lightweight transistor set they could instantly switch on to hear the light program while working in the kitchen. The retreat was immediate and highly visible to the British radio trade. By handing the Brimar brand to Thorn, STC essentially surrendered its influence over the domestic repair bench. The Colster Brandis consumer wing, still operating out of the Footscray complex, felt the chill of this retreat instantly. Without the massive internal subsidy of STC's proprietary valve manufacturing driving their circuits, KB became just another cabinet maker fighting for survival on an increasingly crowded, unforgiving high street. STC's American parent company, ITT, began consolidating its consumer electronics divisions across Europe. The proud KB badge on the tuning dial was slowly appended with the ITT logo, becoming ITT-KB, a corporate compromise that diluted the original trusted British engineering identity. Force 3. High street retail, rental chains, catalogs, and online price pressure. The distribution ecosystem that had sustained STC's domestic dominance began to fracture. High street electrical shops, independent radio dealers, and major chains like Radio Rentals began demanding lightweight, instantly operational plastic sets. The local repair counter, once a highly lucrative continuous pipeline for STC, where engineers constantly ordered Brimar replacement valves from thick trade catalogs, found its economic model completely disrupted. When a glass valve burned out in 1955, the customer paid for a new Brimar valve. But when a cheap transistor radio eventually failed in 1968, the modernizing British consumer increasingly chose to simply throw the entire set away and purchase a new one. The culture of domestic repair, which STC had dominated and relied upon, was slowly being replaced by a culture of disposable electronics. Force 4. Imports, private labels, and good enough listening. As the 1960s progressed into the 1970s, the British consumer radio market was completely overwhelmed by a tidal wave of Japanese and Hong Kong imports. These imported transistor radios were manufactured using highly efficient, cheaply produced printed circuit boards. Boards carrying electronic components and copper tracks that connect them, replacing the expensive, point-to-point hand wiring of the valve era. Companies like Sony, Sanyo, and Roberts were redefining the portable market, but the true damage to the traditional British manufacturer came from unbranded or supermarket label imports. STC's remaining consumer proxy, the Colster Brandis brand now operating awkwardly as ITT-KB, found its premium, British-made sets entirely priced out of the entry-level market. The cheaper imported radio did not need the rigorous military-grade engineering that STC had championed for decades. It did not need to survive a bomb blast or last for 40 years on a sideboard. It only needed to reliably find BBC Radio 1, the new pop music station launched in 1967, while sitting on a kitchen worktop. The British public actively chose affordability and convenience over-engineered domestic permanence. Force 5. Technological, retail, and listening culture shift. The ultimate force that erased standard telephones and cables from the British high street was a fundamental shift in how information moved globally. The deepest irony of STC's domestic decline is that their own engineers were actively inventing the technology that would render their old infrastructure obsolete. In 1966, an STC engineer named Charles Cow, working at the Standard Telecommunication Laboratories in Harlow, successfully demonstrated that light, rather than electricity, could transmit vast amounts of data through ultra-pure glass fibers. Fiber optics would eventually replace the heavy copper cables, the microwave relay networks, and the physical constraints that STC had built its original empire upon. Faced with this massive, highly lucrative industrial frontier, STC's management deliberately retreated from the home. The consumer connection was completely severed by choice. The Brimar valve name, now managed by Thorn, eventually became little more than a heritage badge, increasingly stamped onto valves imported from Eastern Europe or Asia as British glass production became economically unviable. The Colster Brandis consumer brand slowly faded into obsolescence, eventually disappearing entirely as ITT sold off its television and radio divisions. STC management consolidated their entire corporate focus on deep-sea submarine cables, massive digital telephone exchanges, and lucrative military contracts. The physical infrastructure that had once defined British broadcasting began to vanish. The massive New Southgate factory in North London, which had survived the Blitz, the V-1 flying bomb strike, and decades of industrial churn, eventually became too large, too old, and far too expensive to maintain in a modernizing post-industrial London. The massive workforce was slowly reduced. The high street connection was entirely lost. The local repair counters no longer ordered STC components. The mail-order catalogs dropped the STC and KB brands entirely, replacing them with cheaper imports and modern music centers. The corporate structure fractured completely in the late 1980s and early 1990s. The parent company changed hands. The core telecommunications brand was eventually absorbed by the Canadian giant Nortel, erasing the name Standard Telephones and Cables from the industrial registry. The historic factories were systematically slated for demolition. The detailed service manuals, once vital for keeping the nation listening, were filed away in forgotten archives or thrown into skips. The precision glass-blowing tools at Footscray were sold for scrap. The repair counter closed. The catalog dropped the set. The factory fell silent. The badge moved overseas. The glass stopped glowing. The market moved on. Today, Standard Telephones and Cables as an independent British manufacturing empire does not exist. The corporate death of STC in the British market was absolute, leaving no modern consumer electronics behind. Unlike Roberts Radio, which survived by turning its history into a premium design aesthetic, or Bush, which was licensed out to become a badge on supermarket electronics, STC completely vanished from the high street. The parent company, ITT, eventually divested its European consumer electronics divisions, taking the Colster Brandis name with it into the archives. The core industrial telecommunications business was eventually absorbed by the Canadian networking giant Nortel in the early 1990s. The Braemar valve brand, handed over to Thorn in 1960, was slowly diluted. It became little more than an ink stamp applied to valves imported from Eastern Europe or Asia, until the sheer lack of domestic demand for vacuum tubes closed the trade catalogs forever. There is no modern STC DAB radio sitting on a British kitchen worktop. There is no smart speaker carrying the Colster Brandis badge. The names standard telephones and cables faded completely from the industrial registry. But within the British preservation and enthusiast community, STC remains an absolute, undisputed titan. On vintage radio forums, at amateur radio clubs, and across the folding tables of British Vintage Wireless Society, swap meets, the name Braemar still commands profound respect. Radio collectors, restorers, and audiophiles actively hunt for new old-stock Braemar valves, paying highly premium prices for pristine, unused examples still folded inside their original blue and yellow cardboard boxes. When a restorer in a British workshop carefully unboxes a Braemar output valve, they are not merely handling an old spare part. They are holding a piece of industrial-grade telecommunications history, scaled down for the domestic sitting room. When that same restorer places a 1950s STC valve onto a heavy cast-iron AVO valve tester, sets the exact heater voltages, and watches the analog needle swing firmly into the green good sector, they are verifying a piece of British engineering that has survived flawlessly for over 70 years. An old British valve radio with a safely repaired capacitor, a cleaned glass tuning dial, and an original STC valve still glowing warmly inside its chassis can do something a modern smart speaker often cannot. It makes the act of listening feel physically attached to a specific place, not simply because the cabinet is old or because the valve smells faintly of warm dust when heated. It matters because the act of analog tuning still asks the listener to meet the broadcast signal halfway, relying entirely on the physical integrity of a glass vacuum tube manufactured by skilled British hands in Kent in 1955. The room does not care about the modern wireless network. The set either finds the voice in the air, or it does not. The physical sites of the sprawling STC empire have been almost entirely erased from the British landscape. The original North Woolwich Cable Works, where thick tarred submarine cables were once drawn out toward the Thames, was repurposed and redeveloped following the decline of London's docklands. The vast New Southgate factory in North London, with its heavily reinforced wartime headquarters, its massive assembly floors, and its expansive sports grounds, where thousands of employees once gathered for the annual summer fete, was completely demolished. Where engineers once built the infrastructure of British broadcasting, modern housing estates and retail parks now stand quietly over the concrete foundations. The Footscray Valve Factory in Kent met a highly similar fate, its massive glass-blowing infrastructure replaced by modern, anonymous commercial units and residential developments. The physical footprint of the invisible radio giant was systematically scrubbed from the map. Yet, a deeply poetic surprise footnote remains firmly embedded in the modern world. The ultimate legacy of standard telephones and cables is not just the glowing Braemar valve. It is the technology that rendered that valve entirely obsolete. In 1966, the STC engineer Charles Cow, conducting advanced research at the Standard Telecommunication Laboratories in Harlow, Essex, fundamentally proved that data could be transmitted as light through ultra-pure glass fibers. His work at STC essentially invented the fiber optic technology that physically powers the modern high-speed internet. Every single time a modern listener commands a smart speaker to stream an internet radio station into a British kitchen today, That digital audio signal is traveling through the exact technology that STC engineered to replace its own copper wires. The company built the technological tombstone for its own radio empire, and in doing so, built the nervous system of the modern world. This story reveals the brutal, unsentimental efficiency of the British electronics market. A company can lay the heavy communication cables, build the massive transmitters, co-found the BBC, and manufacture the delicate glass valves that give a nation its trusted voice. It can employ generations of skilled workers, absolutely dominate the high street repair bench, and push the very limits of the technological frontier. But when the fundamental nature of listening changes, from glowing glass valves to cold transistors, from heavy copper wires to invisible glass fibers, from domestic repair to cheap replacement, heritage offers no protection whatsoever against obsolescence. What Britain says it values in honest engineering is rarely what the market rewards in convenience. The massive factories are gone. The corporate name is entirely forgotten by the general public. But deep inside a wooden Colster Brandis cabinet, hidden away on a high shelf in a British shed, or resting quietly on a restorer's bench, an original Brimar valve still holds its vacuum, its thick glass clear, its pins perfectly straight, waiting for a hand to turn the bakelite knob. Let the current flow, and find one more voice in the air. See you in the next video.